Okay, so we're going to try this problem here. But before we do, we're going to talk about simplifying fractions with exponents and bases. I know that you know that this is going to be x to the power 3. Because if I write this out, it's x times x times x times x times x, 5 of them, and 2 x's here. And we go, in essence, we cancel out this, which is 1. We cancel out this, which is also 1. And so when we put all these x's together, we're asking how many x's to what power is left with multiplying. We're not actually multiplying the x times x. We're looking when we simplify x to what power is left. And we also know that we can shortcut this process by subtracting the upper minus the lower exponent. So when we turn to a scenario like this one, the 3, the base, is like the x. We're going to try and see if I could write out 3 times 3 times 3 times 3. I'm going to have x plus 1 of those, which I can't really imagine because it's variable. And on the bottom, we're going to have 3 to the 1 minus x of those 3's. And so there's going to be a lot of them. But ultimately what I'm going to do is I'm going to then cancel them out. And I'm going to end up with 3 to some power. Well, how am I going to find the power? Well, I subtract the top minus the bottom. And so when I do this, I can do the top exponent minus the bottom exponent. And so when I do the top exponent minus the bottom exponent, let me just move this out of the way. Now it's just a matter of doing algebra. The base stays the same, and it's x plus 1 minus 1, distribute the negative sign, plus x, which is 3. I get x plus x is 2x, 1 minus 1 is 0, and so I get 3 to the power 2x. And so I used my rules of exponents on a base of 3. Okay, so now when I have this scenario is the same thing as saying, let's say, a cubed times a to the 5th over a to the 6th. I know I add my exponents base, I get 8, and then I subtract these and I get a squared. Well, this a can be anything as long as they're all the same. That's the process I'm going to do with this one. And so I do know that if I write this one out, I'm going to write this out a little bit. It's going to be 4 minus 3y squared times 4 minus 3y squared times 4 minus 3y squared. That's this first part here. Then I'm going to do 5 more of them. 4 minus 3y squared, and so on. I don't have the space to write them all out. Over on the bottom, well, in total, before I get to the bottom, in the total then, there was 3 from the first one and 5 here. So in total, there's 8 of these 4 minus 3y squares on the bottom, on the top. On the bottom, I'm going to have 4 minus 3y squared, and I'm going to have 6 of them on the bottom. There's 6 of them. Same as what we have here. There's 3, 5, and 6. If I put it all together using my rules of exponents, I know I'm going to have 4 to the 3y squared. I have 8 of them up top. And on the bottom, I have 4 minus 3y squared. I have 6 of them on the bottom. Well, I can cancel this whole factor and this whole factor because this is 1. And so on. I can cancel them all out. I can cancel 6 of them out, which will in essence leave me with 4 minus 3y squared to the 8 minus 6, which is 4 minus 3y squared. Okay, so I hope that helps a little bit with those two kind there.